Hello, my name's Tony Edwards. I'm the CEO of Step Change Global, and it's my great pleasure to welcome you to the Digital Energy Leaders Summit and our panel session on how new technologies and operational models are enabling the next generation of minimum staffed and unstaffed operational models and facilities. So it's my great pleasure to have a very distinguished panel group here today, and I'd first like them to introduce themselves and their affiliation, please. Starting with you, Oscar.
Okay, hi, my name is Oscar Abbink. I'm Dutch, so apologies for the accent, but and I'm a research director with IHS Markit.
Saeed.
Hello, Tony, and thank you for the introduction. I'm Saeed Mubarak, representing the Society of Petroleum Engineers Digital Energy Technical Section. Thank you.
And Mikhail.
My name is Mikhail Korolkov. I represent Gazprom Neft, which is an oil company of Gazprom Group. I am head of Digital Technology Center, responsible for digital innovation in the company, starting from long-term digital technology strategy into innovation program itself.
Thank you. It gives me great pleasure to moderate this panel, as this is a subject which is very close to my heart. In a previous life, I used to operate unmanned platforms for BP in Southern North Sea. So it's good to see this approach getting some attention again, and also being enabled by the latest digital technologies, which are enabling more complex unmanned and unstaffed facilities to be developed. So just to kick off, what I'm going to do is just give some background and content to the panel session, and then we will have a discussion going forward. What is the context? Well, in the current situation of a low oil price, current operating models and organizational models that we've seen over the last 20 or 30 years are really unsustainable, and both brownfield and greenfield projects are looking to not only maximize production and optimize recovery, but significantly drop OPEX and CAPEX. And what we see is many operators have pulled many of the traditional levers and are now looking at how they get the next level of performance. And one of the opportunities is to look at digital technologies and how they enable unstaffed and minimum staffed new operational concepts. What we see is there's three levels to unstaffing and minimum manning. One is operations engineering support, which is now pretty common in many parts of the world. Certainly it is common in the North Sea and in many other basins, where you have operations and engineering support supporting operations in the field, whether that's land-based or offshore. The next evolution is the application of remote control to those operations. And we see that this is increasingly an emerging trend for greenfield operations, but also beginning to emerge for brownfield operations. And we'll give you some of those examples. And then third is what we might call radically unstaffed or minimum staff project concepts. So what if we took everything we've learned over the last 20 years on digital transformation and all the latest technologies and threw them at a project concept? What could we do? And how could they be designed to be minimum manned from day one? And and what does that do to the economics, and what does that do to the way we run these operations? Now, just some examples that we've been involved in of operations and engineering support centers. Typically, this is what you kind of see. You see teams optimizing production, optimizing engineering and maintenance support. And these centers are located in offices, and they are supporting operations, land-based operations or offshore operations remotely. The next evolution is the remote control of these operations, and this has been less common, but we do have some examples in oil and gas. Santos have been operating their GLNG gas wells and upstream facilities since around 2012 remotely from the centre of Brisbane. The middle example is Martin Linge, which was initially a Total design, is now operated by Equinor, but this is remotely controlled from the beach. And we have a couple of mining examples here. One is the iron ore value chain in Perth, and the last one, this one over here, is what is the biggest mine in the world by a tonnage, Escondida in Chile, which is operated by BHP, and that's now being remotely controlled from the center of Santiago. And also we see examples in midstream. So this is a new project where a midstream operator is looking to remotely control all its oil and gas facilities and pipelines remotely, again, from a city center location. There are some examples of radically minimum staffed and unstaffed project concepts. Most of us think of unmanned platforms as these kind of wellhead towers, and these are still being designed and implemented, and the current state of the art is moving towards a visit frequency of once a year. But there are some great examples of operations which are much more complex and are unmanned. So this central one is Woodside Angel. It's been up and running since 2008, and it's unmanned, unstaffed, remotely controlled, and they visit it once every 60 days to do the maintenance. The one in the top left-hand corner is Pohokura, which is in New Zealand. And again, this is a remotely controlled and unstaffed operation. And we see this now beginning to be seen in many other types of operations and projects which are currently on the project runway for FPSOs, for SAGD operations and floating production facilities, as well as many land-based multi-well type operations that you typically find in unconventional developments. So that's really all I was going to say on this. And first of all, I'd like to ask Oscar, what are the other trends that you see going on in the oil and gas sector at the moment, which are affecting the way we think about unstaffed operations and unstaffed project concepts?
Thanks, Tony, and thanks for the great introduction. Yeah, and a good question. So actually, one of the fortunate things at IHS Markit is that we look at this whole landscape, and there's actually a couple of drivers, and the key one you already mentioned, it's cost. Traditionally, companies have been looking at cost, obviously. A second thing is safety. So those are sort of the traditional drivers in the oil industry to reduce manning in the field. But we've seen lately, in particular with this downturn, there's two things or a couple of things that are actually different. So the first one is the previous downturn, much of the cost reduction came down on the suppliers. So reducing their margins gave the operators the possibility to actually reduce cost. We don't expect that the suppliers have much margin left to reduce anymore. So that means that operators have to look at another element. And the second thing is that there's this carbon footprint reduction trend going on. And so often that's combined with cost reduction, because most companies recognize if you reduce your emissions, you at the same time reduce your cost. And so you see a focus on that. So that it's around obviously transportation and logistics, the use of fuel to literally source operations in the field. So these drivers are also pushing for companies to look at their manning. And as you said in the very beginning, Tony, so it's not really about the technology, but it's really changing the operating model, the way that companies operate their facility, which is now driving basically this cost reduction. And demanning is one of the main sort of opportunities where you have both from a cost perspective as well as from a carbon footprint perspective, have a lot of possibility to have a good impact. So, and I'm sure that, Mikhail and Saeed have seen examples in their work and in their surroundings.
So, Saeed, I mean, is this something that you're seeing from your perspective?
Well, Oscar, thank you very much. You mentioned two main, basically, drivers for it, cost and safety. And what comes more of, there has to be some sort of a balance among the cost, safety, regulations, reliability, and sustainability as well. It can be always a compromise there. The drivers, for the drivers of these initiatives. Definitely, there is no one size fits all. There are offshore, onshore, IOCs, NOCs, and there are basically greenfields and brownfields. Every single one has its own basically challenges and opportunities. So you mentioned some sort of you mentioned the drivers to it. It's just like the business models. They have to be more of adapting the new modality for it. And technology has to be more of really selective to be really reliable. And when it comes to national oil companies, they might differ from the international oil companies when it comes to other commitments other than the operation itself. Definitely, they need to operate it in a safely manner, very cost effective, but they have responsibility towards basically the nation itself, other than the international oil companies where maybe the driver or the main driver is basically cost. That's what I see. And
yeah, and Mikhail, I mean, how are you seeing it from where you're sat in a very large national oil company? Is this a big driver for you to move in this direction?
Yeah, definitely. It's a big driver, especially taking into account the, let's say, landscapes in which we operate, which is far north, very cold, very remote locations with no infrastructure and very harsh conditions, where it's just at least non-comfortable for people to work, and also it's of course not safe. And then concerning drivers, I agree on drivers like cost and safety. I would add that there is one more driver in our case. It's a lack of skilled personnel who is capable to work, especially in such conditions. And from this point of view, at least in short term, key driver is not key driver, key opportunity for us is not even cost reduction, but extending people. So not replace people, not reduce capex through simpler facilities, let's say, but extend people, get capability to operate in the places where we just didn't have enough people or didn't have a possibility, other possibility to work. And also I would say that we address not only drilling and production as a target for, let's say, unmanning, which is traditionally addressed. We also are interested in unmanning of exploration and construction. These are also, let's say, huge activities which take place in really nasty places, and we also are thinking about unmanning of these activities too.
Yeah, I think you've picked up on a very interesting point. I mean, certainly we see that, the remoteness of your operation is a big driver on going this way. When logistics become very difficult and the conditions that you're expecting people to work in become very harsh, it becomes pretty obvious to do things remote and minimum manned. But obviously this approach is enabled by the advent of digital technologies, high bandwidth comms, data collection and storage and other things. I mean, what are the kind of technology drivers that you're seeing to promote going towards more unstaffed and remote and more complex types of facilities? I mean, starting with you, Oscar.
Yeah, as you said, Tony, I think there's a whole range of technologies that are enabling this at the moment. It starts, and indeed, at the fact that you have local sensors nowadays. Then of course your communication means are much better. But at the same time, and I'm sure we can mention a few more, but there's one particular aspect that I want to mention. Also, Michael was referring to it, is that in particular, the young generation is so much more accustomed to working with digital, and anybody who has kids, the amount of time they spend on their phone or iPad is tremendous. So they're much more, let's say, already grown into this new system that we sort of old men here are a bit, perhaps had to learn during our lifetime. They grow up with it. And so one element is clearly that as these technologies come available, and you can mention others like digital twins, and all the advanced analytics, the AI and machine learning, etc., the high performance computing. Michael mentioned exploration and field development, and so all that becomes available. At the same time, we see this new group of people coming in there would also maybe expect this to be. They don't expect to go out and go to a shop and buy something. They do that online. And I expect that in the future, more and more people, young people, are willing to use the same online tools to do their work and see what's going on in the field. So I think that the combination of that is really spurring this this technology push into the oil field.
So you know, say, do you think that the combination of the current low oil price, you know, the development of some key technologies, plus maybe even the COVID-19 pandemic, are pushing us towards a tipping point where, you know, this is going to become much more common than it was in the past? I mean, what's your
we have to be really realistic when it comes to what you know, COVID-19 and oil prices, you know, the downturn brings. I mean, what they bring with them is basically delays in construction, maybe even canceling projects, and maybe deferral even of maintenance. And definitely for those platforms, let's say, or sites that are really instrumented by reliable systems, well, they're unmanned anyway, so we're not delaying anything. So that's a positive thing when it comes to ready and you know, available unmanned basically sites. But when it comes to new advancements in these things and maybe new projects, I think the pandemic and the low oil price would slow that in the oil and gas because they're really expensive, and companies have been laying off you know, experts now. So when it comes, go back to Oscar's point, when it comes to our children are basically used to the technologies, which is really true, but there is no replacement for fundamentals in the oil and gas. I mean, we need really experts, and I would go to Mikhail. Basically, he mentioned the lack of experts, that they need to be really replaced with expert systems, and definitely experts will do these systems, be it APCs, automated processing, you know, control systems, twin, let's say, you know, twins and other things. But when it comes to these, I mean, more of the digital twin, the oil and gas in particular is extremely advanced in that domain, because they're generators of data. So when we speak about data, the oil and gas, since day one, was a generator of massive data. And in fact, the first, let's say, you know, would say edge computing and, you know, digital twin, maybe was constructed for oil and gas fields, because we have all simulation models for subsurface, basically infrastructure, and even wells and even facilities, be it, you know, using numerical simulators or transient simulators. So still, I would say there is no replacement for fundamentals. We're capitalizing on all these technologies in the digital domain as enablers, and they're really extra tools that we can get benefit out of whenever they are fit in the right place.
So Mikhail, if you put all of this together and in a company like Gazprom Neft, you know, what does it add up to? I mean, what's the vision that you're driving towards for the way you're going to be operating your, you know, new facilities and your old facilities over the next, I don't know, 2, 3, 4, 5 years?
So our vision is that in short term, everything will be around data. We already mentioned data, like Saeed mentioned, that oil industry generates a lot of data since many years ago. And now the question is to produce even more data, and then, how to say, manage and use those data better than we used to. So it will be all around analytics, digital twins, data platforms, different collaboration rooms where people work with data and analytics together in producing decisions. So in a few years, it will be all around data analytics and digital twins. But then the question is that still we are very physical industry, and we need to move things physically. We need to transform things physically, and then you cannot just move and transform things with data or analytics without someone going there and moving it there. And then probably it will be finally about robotics and different kind of robotic devices. For example, we already start experimenting with unmanned heavy vehicles which deliver a cargo to our oil field, because again, the oil field is 100 kilometers from a nearby city and in an absolutely empty place, and you need to drive over snow there, and it's unsafe, it's costly, it's difficult for people. That's why we are already trying to employ some unmanned vehicles to deliver, at least experimenting with that. And the more we going into the future, the more things like this will be used, and we will need more robotics, more unmanned technique. But I also agree with Saeed when he said that first of all, equipment should be reliable. And this is the basis for unmanning. So we also need to implement more reliable equipment in the field. And this will be very basic. Typically, we forget about that. When we talk about unmanning, we talk about data analytics, remote control, even robotics. But the basics is to have reliable equipment in the field.
Yeah, because reliability is more of associated with longevity as well. I mean, if you don't want it to be manned, then you have to make it that reliable. And definitely it's very correlatable to cost. And maybe companies and service companies and technology providers need to invest. I mean, the whole industry, in fact, need to invest in more reliable technologies for a long term as a whole. And so they need all collaboration is a key there between all the companies. And you mentioned the drones, and drones are basically used in various aspects in the petroleum business, from exploration to even maintenance. So be it on air or subsea as well. So they're there, they're available, and they're reliable when it comes to their application, and they're really designed for certain applications, just like collecting seismic data, maybe even inspecting chimneys. I mean, you don't have to, construct a scaffolding just to see what's happening in a chimney. So these are the things. When it comes to the artificial intelligence and data science, then the word that you have mentioned, Mikhail, is very important. Again, it's reliability of data. And this is always skipped when it comes to discussion on AI and data science. Data reliability is a must because we make decisions out of the data, and some of the decisions tend to be bad decisions. It's not because we intend to, it's because we based it on data that is not maybe 100% right.
I mean, there's a number of interesting points there. I totally agree that if you're going to go unstaffed or even minimum staff, reliability and having good equipment is absolutely imperative. And what we see companies who are doing this well is, instead of getting high availability by going down the traditional route of sparing machines, they actually, instead of buying 3 50% pumps, they buy one good 100% pump. But the route to that is the fact that the way we've traditionally procured those pumps, by having the lowest cost technically acceptable bidding process, is actually not helping us. In fact, it's getting in the way of delivering these kind of concepts. So, with that thought, Oscar, if something like procurement can be a barrier for us to do this, what are the other barriers that are out there? I mean, and we've already heard that, we think most of the technology is already there. So clearly the barriers are maybe not technological. So what are the other kind of barriers that you're seeing getting in the way of us successfully delivering these concepts?
Okay, now it always becomes more personal opinion, but I guess as you said, the barriers are not so much on the technological side, and we look at and I guess you have the same thing, when we look at these projects that have these really large scale unmanned operations going on, I think there are two key sort of elements that stick out. First of all is senior leadership commitment. So it's really where senior leaderships, we're going to do this. We know we may run into issues that we cannot foresee at the moment because we're doing something unique, but we're going to push it, and we're not going to punish the staff that is involved with these projects. So that's one thing. The second thing, and we actually have a number of case studies around that, is that it's the company culture and it's the willingness of people to change. So one of my most interesting case studies, where the case studies for us, industry case studies, is where we go into a company, we talk to them, we describe what they did, how they implemented new technologies, and then we try to capture the benefits and also the challenges. And one of these was really about remote maintenance, where they would take the maintenance staff from offshore platforms to an onshore center, and then have them go there if there was really an issue. And what you saw is that the offshore installation managers, they really wanted their staff at their hands offshore, so they weren't able to let go. So we saw this reduction in helicopter flights, in offshore costs, about 40% in a couple of years. And after again a couple of years, everybody was back offshore. As soon as the leader that sort of governed that change was gone, then the offshore installation managers took their chance and pulled everybody back out again. And so you see that companies really struggle with that. And and again, younger generations, apparently it's easier, but in general, and there are also in any generation people who are willing to change, but having staff willing to change, able to change is one element. Senior leadership is definitely another one. And if they're not there, there are big barriers.
Well, that brings more of continuity as a very important thing, be it continuity of the strategy itself, continuity of maybe the team itself, because they build even experience with the domain. People are scared of what they don't know. So if you change leadership, new leadership comes that they're used basically to a certain workflow, and definitely they would rather go to their comfort zone. Now, just to add to Oscar's point when it comes to the difficulties and maybe challenges, and this is really great, Tony, that you mentioned it. It's the workflow, the existing workflows that the companies basically, adhere to. One of them is just like you say, the contracting and procurement. But before that is the trial testing and approval of technologies. It's just like every company has its own trial testing procedures, and there are multiple stages. And I mean, they're not allowed to fail anyway. So these projects are expensive. Some of them are really risky. So the reliability, again, has to be really close to 100%. And especially in the domain of this particular subject that we're discussing. So there is no tolerance, in fact, especially if you go to areas that are not only remote and maybe close to residential areas or risky areas or borders and other things. So reliability is an important thing. So you go back to trial testing, it goes to maybe years, multiple years. By that time you finish approving a technology, maybe a new version of this technology is already surfaced out and maybe already implemented elsewhere. So you see, these processes can be eliminated if close collaboration again between companies, even similar companies, it's okay. I mean, size-wise maybe, or objectives, the overriding objective. Let's say national oil companies within a similar region with similar oil fields, similar challenges. The trial testing of similar technologies could be done by one, so the other one could avoid or at least enhance the process of approving these technologies. Could be expedited, for instance. That's another challenge, Tony, that I would like to, I hope I covered.
Very good. And Mikhail, your thoughts on, the barriers and or the opportunities that we have in front of us.
Yeah, first of all, I agree with Oscar and Saeed that there are internal barriers, like in organization and processes and culture. Change is always a difficult thing, and this change is rather radical, so it really is not easy. Concerning external barriers, I would mention regulations, because at least in our country, in Russia, we see that we have a lack of regulations which just allow unmanned operations in many cases. In many cases, you need a person to be present to approve something, to justify that something is done right, and it just you cannot remove that person without breaking the law. Finally, so it needs, at least in our case, regulations should be updated and changed. And also with the technology itself. Yes, there is a lot of technology already present, like drones which fly. Yeah, we use them because, and this is like mainstream already. We use, as was mentioned, from exploration to monitoring of assets and monitoring of construction, etc. But for example, if we take ground vehicles unmanned, this is new, and this we have just first experiments with them. And they may drive in California, but it's very different to drive in 100 kilometers in snow fields in nowhere. It needs a different technology, just from point of view of artificial intelligence, of computer vision, etc. And then the barrier is how you adopt this technology. There is almost nothing out of the box. All these new technologies, they need adoption within a company. There is nothing which works, which you can just copy. You need some process inside to scout for it, to somehow adjust it to your needs, to integrate it into your system, into your processes, change your processes, etc. And this is, let's say, a new discipline which needs to be built in the company, and we, at least in our case, we are heavily working on this, in bringing this discipline into our company, learning the hard way how technology can be adopted, invented, adopted, integrated, all these things. This is about barriers.
Very good. I mean, just to wrap up, you know, one story that we got from when we went to visit Pohokura, New Zealand, was that project and operation as a gas production system was designed to feed a single gas-fired power station that was going to, you know, keep the lights on in Auckland. So the project driver was, you know, very, very high uptime, in excess of 99%. But the thing that was interesting was that the project director and the operations manager made the leap that the only way to get very, very high uptime was to take the people away. And that, because the people are involved in causing some of the downtime, you know, as we all know from, you know, HSE investigations. And they came up with the operating model, which they called one man and his dog. And the one man and his dog operating model was the man was there to feed the dog, and the dog was there to stop the man touching anything. And so this was how they kind of overcame the, you know, some of the resistance. So with that, gents, it's just my pleasure to thank you very much for this panel session. We are now going to take some questions as a follow-on, as a live event. And so hopefully, you know, that you've been thinking about those questions and they're all coming in, and we'll see you shortly. Thank you.